Okay, example, adding vectors by components. A1 equals 1.41 meters up and to the right, 45 degrees above the horizontal. A2 also equals 1.41. A3 is defined. You're asked to find the sum, A1 plus A2 plus A3. So here's A1. We can draw it right down there, up and to the right. A2 is the same length, down and to the right. And A3 is longer, about 2 meters down to the left. So that's our sketch. Let's define a y-axis is to be up, x-axis to be to the right. And what we're going to do is make a table where we list the x components and the y components for each vector. So let's start with A1. We can draw a little right-angled triangle showing there the 45-degree angle, A1y and A1x. So A1x is the length times cos 45, and A1y is the length times sine 45, which you can see from the trigonometry. A2 triangle looks like that. There's your right angle, there's your 45 degrees. So you can see now that the x is also 1.41 times cos 45, and the y is negative 1.41 times sine 45. And A3 will draw a triangle for that down to the left. Now both the components are negative x and negative y, where the x will be the length times cos, and the y will be the length times sine, both negative. So we can plug all these values into our calculator and just add up the x components, and we get 0. If we do the same thing with the y components, we add them all up, you can check me, you get negative 1 meter. So the final vector is down, and it's 1 meter long. It's 1 meter down. So let's try that same example again, but this time tilt the axes by 45 degrees. So there's the problem. We draw A1 up and to the right, A2 down to the right, and A3 down to the left. But what we have to look at here is that A1 and A2 are perpendicular to each other. They're just both tilted by this 45 degrees. So we can define y to be parallel to A1 and x to be parallel to A2. So then the y component of A1 is just A1, and the x component of A1 is 0. And the x component of A2 is A2, and the y component of A2 is 0. So those were easy, and the only one that needs trigonometry is A3. We can look at this angle now is 45 plus 26.6, and in my calculator it's 71.6. So we can now draw a tilted triangle for A3, where the angle there is 71.6, and both these components are negative. So let's again make our little table, x and y. For A1, it's very simple. You just write 0 for x and 1.41 for y. For A2, it's 1.41 for x and 0 for y. For A3, we now need to use trigonometry, the negative length times cos for the x component, and the negative length times sine for the y component. So when we add those all up, we now get plus 0.703 meters for the x and negative 0.715 for the y. So the total length of the vector, you have to add the sum of the squares, Pythagoras, you get 1.0 meters. And to find the angle, you have to do tan to the minus 1, and we get pretty much close to 45 degrees there. So this is the same vector we had before, but it's just tilted on our new axis down to the right by that 45 degrees. So both methods give you the same physical result, but the second one is just a little less work.